So we're back and we're working on example 3, A and B, and we're given some information and we have to sketch a graph of a continuous function with the given characteristics. Now we're sketching the graph of f, and so we need to think about a couple of things and think about what some of these things mean, right? So if f of 0 is equal to f of 2, that's equal to 0, so that's not a big deal. That's just where our intercepts are. Now, if we have f prime of x is greater than 0, so f prime of x is greater than 0 if x is greater than 1. And so that means, right, my derivative is positive. And think about our fun chart. What our fun chart tells us that if our derivative is positive, then our function is increasing. Our function is increasing on that interval. If f prime of 1 is equal to 0, that just means we have a horizontal tangent line. And finally, if f prime of x is less than 0 for all x values greater than 1, that means that my function is decreasing on that interval. Now, here's where things are going to get a little more fun. It says f prime of x is less than 0. So, I'm sorry, f double prime of x. So my second derivative is always negative. So this means that my function is always concave down. On that interval. So let's get some scale over here. And the easiest scale to start with would be this guy, f of 0. We know f of 0 is 0. And we know that f of 2 is also 0. So let's go 1, 2, 1, 2. That is also 0. So f of 0 is 0 and f of 2 is also 0. Now we know that the function has a horizontal tangent line at f prime of 1. So when x is 1, we have some kind of horizontal tangent line up there. And think about like when we're doing our table of values, right? Like our sign charts. We know that if x is less than 0, if x is less than 1, that our function is increasing. And so my function should be increasing. Remember, this is a continuous function, and we've got a whole lot of derivative stuff in here. So this thing should be continuous, and it should be differentiable. So my function's increasing till we get to an x value of 1, and then my function is decreasing on that other interval. And this is the graph of f of x. And so if we kind of piece all these things together along with our fun chart, you should have your fun chart sitting right next to you so you can look at some of these things. It shouldn't be too terrible. This next one is a little trickier. So we have f of 0 is equal to f of 2, which is equal to 0. So again, on those intervals, right, 0 is 0 and 2 is also 0. But then some things are going to change around a little bit, maybe. We know that our derivative is greater than 0 if x is less than 1. So on that interval, my function's increasing. Same thing as before. The function is increasing. Now here's kind of something a little different. F prime of 1 is undefined. So this would be a vertical tangent line. So we should draw something in here over at 1 when we get into 1 that gives us that vertical tangent line. And they say that f prime of x is less than 0 if x is greater than 1. So if our derivative is less than 0, that means my function is decreasing. And finally, f double prime of x is greater than 0 always, so that means my second derivative greater than 0 is positive, so that means we are concave up on this entire interval. Like this whole thing is concave up. So think kind of about what's going on over here. As we're moving this way from negative infinity we're moving towards negative infinity, we're moving towards 1. My function values are increasing, but, so my function values are increasing, but we are concave up. So my concave up, right, remember? We got concave up, we have concave down, and we can split these pieces up a little bit, and that's what we're going to do here. So we could write, we're taking basically coming from negative infinity to 1, we're concave up. And remember, at 1, we have this vertical tangent line, so it's not some nice smooth curve here. It's pretty sharp. And then from 1 to infinity, we're concave down. Whoops, I missed that line. Let's try this again. We're concave down. And there's the graph of f of x.